Another thing that we do that's probably unique to us in a way is we identify the magnetism that might be induced in the motor. Crazy as it sounds, motors are magnetic, but that's through induction. That's through an electromagnetic field with a winding. We're talking about magnetism that you could put a screwdriver against the end of the shaft and have it hold on the end of the shaft. You might go, oh, big deal. No, that can be a big deal because the magnetism actually can cause circulating currents. And circulating currents then can damage bearings and cause failure. So we measure the Gauss level of the component parts and we document. And if they're above certain levels, then we recommend degaussing. So we use a Gauss meter similar to that one. And then we have a demagnetizing unit. And in this case, let's just say it's a shaft. We will actually wrap the wires around the shaft, and then we'll run this machine through a degauss or demagnetizing, downcycling, removing the magnetism, and then auto degauss reverses polarity, and it goes back and forth. And when you get done, you could take the Gauss meter and measure it and have a completely different number. In other words, we're removing the magnetism. A great device. Before that, we were chasing our tail on problems with motors because we didn't even realize that that small amount of magnetism probably was causing things like we're seeing from magnetism versus other sources of circulating current.